Hello. Let's talk about how to read a solubility chart, or a way that basically tells us how much of a solute can dissolve into the solvent. Now we're just going to focus on aqueous solutions here. But a solubility chart basically shows different solutes inside a solvent. In this case, we're going to be talking about water. So the x-axis tells us the temperature of the solvent. This chart runs from 0 to 130 degrees Celsius. On the y-axis, it tells us the solubility. Now, if you can, please notice that the units for the y-axis are grams per 100 grams of water. That's just setting a standard. It's saying that all of these solutions are dissolved into 100 grams of water, regardless of the temperature. If I wanted to basically know how much it would dissolve in 200 grams of water, I would just take every number on the chart and multiply by 2. I'd need twice as much water, so I would need twice as much solute. If I wanted to know what would it dissolve into 50 grams of water, well, that's half the solvent, so I'd need half the solute. For instance, let's say that I want to know the solubility of potassium nitrate in a solution that's 50 degrees Celsius. I would go to 50 degrees Celsius, go up till I hit the potassium nitrate line, go across until I read the solubility, and it will tell me that if 50 degrees Celsius, I can dissolve 100 grams of potassium nitrate into the 100 grams of water. So the solubility at that temperature is 100 grams. Because saturation tells us where we are, maximum amount of solute tells us the solubility. If I said that I had dissolved 100 grams of potassium nitrate at 50 degrees Celsius, it would be saturated. So basically, if you plot a point saying I've dissolved this much at this temperature, if you plot on that point here on this line, that line is telling you that it is saturated. If I plotted a point and it ended up being anywhere below the line for potassium nitrate, and be careful, you're looking at the right solute, so anywhere below this line right here, so this entire area, would be unsaturated. If somehow I was able to make it above the line, in this area up here, if I plotted a point, that would mean is supersaturated. So on the line is saturated, below the line is unsaturated, and above the line is supersaturated. Now notice though that most of these things are heading upwards. The general rule for solubility is that when temperature increases, solubility increases. However, this is pretty much for just a solid solute. So notice here that as temperature increases, the lines tend to go up. You can dissolve more sugar in hot water than you can cold water. It's not true for necessarily every compound, but that's in general true for almost all solids. However, the solubility for a solid cannot be affected by pressure. Pressure would only affect the gas. So for temperature, it is directly related to solubility for solids. Be very careful, because for gases, it's the opposite. So here is another solubility chart. In this case, it's showing you different gases in water: methane, oxygen, carbon monoxide, and helium. And here you can see most of them are going down with temperature. With a solid, adding more temperature means the solvent particles are more energetic, more likely to hold on to that solid. But with a gas, heating up the solvent also heats up the solute. And because gas particles are constantly trying to break free, when you heat them up, they move faster, they're more likely to break free. So as you heat up a gas, it's easier for it to escape the solution, and therefore less remains dissolved in there. Temperature and solubility are inverse for a gas. This can have pretty significant consequences. There's something called thermal pollution. So think about this question: can a fish drown? Well, the answer is yes. We have had several problems in the past, hundreds of problems in the past, where factories might take in water from a lake or from a stream or river, not doing anything to it, not putting anything into it, but just basically use it to suck up the heat produced from its reactors or its furnaces or whatever else, and then dump it right back into the water. Well, when they do that, it basically leaches out all the oxygen in the water. So when it comes back out, the fish can't have anything to breathe. There's no oxygen in the water, and the fish literally drown. They can't breathe. So that's why most factories will have things like cooling towers, where you see a lot of steam coming off there to try to let the water, the particles that are the most likely to evaporate, give it time before dumping it back in there. And in a lot of places, it doesn't just dump straight back in, but it's churned a little bit or it's agitated a little bit to try to mix in more water with oxygen, with air. This is a serious problem. So factories do try to deal with it by, again, just letting the water stay out for a little while, letting it cool down a little bit, letting it evaporate into the air, and mixing in with some air too, before being dumped back into the river. That way it doesn't kill as much wildlife and doesn't cause as many algae blooms and be an environmental nightmare. The other factor that can affect solubility is pressure. Think of a soda. When you open up a soda, you hear the little psh. That's because the contents are under pressure. In order to shove that much gas into the water, you had to put it in there at very high pressures. That squeezed the gas into the solution. As soon as you release the pressure, as soon as you open up the container, the pressure drops, and immediately those gas bubbles of carbon dioxide try to leave. So while temperature is inverse with solubility, for a gas, pressure is direct. Hopefully you're able to see this chart, but I'd like you to try to consider this question. Using the chart, please try to find the solubility of potassium bromide at 70 degrees Celsius. Please note that this line right here is for potassium nitrate. I'm asking for potassium bromide, so I'm asking for this line. Consider what is the solubility of potassium bromide at 70 degrees Celsius. Please pause the video and consider. If you go across 70 degrees Celsius and go up, we hit the line of potassium bromide at about 90 grams. So 90 grams of potassium bromide can be dissolved in 100 grams of water. The solubility is 90 grams per 100 grams. Okay, so consider if I had that solubility, if I try to dissolve in 60 grams of potassium bromide at the same temperature, what would you describe the solution as? Supersaturated, saturated, or unsaturated? And then what if I try to dissolve 180 grams of potassium bromide in 200 grams of water? Same question. Would the solution be supersaturated, saturated, or unsaturated? Please pause the video and consider. Well, we just talked about the fact that at 70 degrees Celsius, potassium bromide has a solubility of about 90 grams per 100 grams. If I try to dissolve in only 60 grams of solute, that's less than my 90, the solution could dissolve more, it'd be unsaturated. However, if I try to dissolve in 90 grams into 100 grams, that's called saturated. So if I double the amount of solvent, I could also therefore double the amount of solute. 180 to 200 is the same ratio as 90 to 100, so that is a saturated solution.